Hi, my name is Sanjay Salunke. We have seen last session gravitational force is universal force and it acts not only between two objects on the earth but also between any two objects in the universe. Today we are going to talk about first circular motion, second centripetal force, third Kepler's laws, fourth Newton's universal law of gravitation. Moving towards first point, circular motion. Definition of circular motion. Circular motion is movement of an object along the circumference of the circle or rotation along the circular path. Some example of circular motion: motion of blades of fan, spinning of top, spinning blades of windmill, etc. Our second point is centripetal force. As we all know, centripetal force is the force acting on any object moving along a circle which is directed towards the center of circle. Some example of centripetal force: the moon revolving around the earth is the best example of centripetal force. Some other examples are merry-go-round, planets revolving around the sun. Third example is motion of electrons around the nucleus of atom. Centripetal means center seeking, that is, the object tries to go towards the center of the circle because of this force. Introducing you to the scientist John Kepler. John Kepler was German astronomer and mathematician. He started working as a helper to the famous astronomer Tycho Brahe in Prague in 1600. After the sudden death of Brahe in 1601, Kepler was appointed as the royal mathematician in his place. Kepler used the observation of planetary positions made by Brahe to discover the laws of planetary motion. He wrote several books. His work was later used by Newton in postulating his law of gravitation. Moving towards next point of this chapter, Kepler's laws. Kepler stated three laws describing planetary motion. At first, Kepler's first law: the orbit of planet is an ellipse with the sun at one of the foci. Figure shows the elliptical orbit of a planet revolving around the sun. The position of the sun is indicated by S. Kepler's second law. The line joining the planet and the sun sweeps equal areas in equal intervals of time. A, B, C, D and E, F are distances covered by the planet in equal intervals of time. The straight lines AS, CS and ES sweep equal areas in equal intervals of time. Area ASB is equal to area CSD is equal to area ESF. Next, Kepler's third law. The square of period of revolution of a planet around the sun is directly proportional to the cube of the main distance of the planet from the sun. Thus, if r is the average distance of the planet from the sun and t is its period of revolution, then t square proportional r cube, that is t square upon r cube is equal to constant. Next point is Newton's universal law of gravitation. Every object in the universe attracts every other object with a definite force. This force is directly proportional to the product of the masses of the two objects, and it's universally proportional to the square of the distance between them. Expression of this Newton's universal law of gravitation. Consider two objects of masses m1 and m2. We assume that the objects are very small spheres of uniform density and the distance r between their centers is very large compared to the radii of the spheres. The magnitude F of the gravitational force of attraction between the objects is directly proportional to m1, m2 and universally proportional to r square. That is F proportional m1, m2 upon r square. Therefore, F is equal to g m1 into m2 upon r square, where g is the constant of proportionality called the universal gravitational constant. We will continue in next session. Thank you.